Hello everyone, this is Manish here. And today we are going to basically start with collections in Java. So as we proceed, we are going to take ahead various types of collection that we have in Java. So guys, what does basically collection means? So collection, we are going to see that it is a group of uh, separate framework that we see, and these are binded as a single unit. Exactly is a list. So list basically is an interface that provides the ordered collection. So it is a child interface of collection, where it is an ordered collection of objects in which duplicate values can be stored. And list also preserves our insertion order. We'll see that various classes going to implement list interfaces. That is, we'll see through ArrayList first, and then we'll see the other examples. So as we go through the ArrayList, what exactly ArrayList that we see, guys? So Java ArrayList is part of the Java collection framework and is a class of java.util package. So it provides us with the dynamic array in Java. So though it is slower than arrays, but it can be helpful with a lot of manipulations in the arrays needed. Okay. So the main advantage of ArrayList is that if we declare an array, then we'll have to mention the size. But in ArrayList, you do not have to mention the size. So it is more of a dynamic arrays you can think of. Okay, so we'll see an example through this. Now, as I told you, basically lists is going to be similar to arrays. So it's a linear structure that you can think of, like we have it in arrays where you have respective indexes and you can store values into it. So in the given program that you see on my screen, what are we doing is we are creating a array list object, and the type of array list that it is going to have is going to be string. Okay, and then add is the respective method that we use to add certain values into a list. So right now we are seeing that we have defined strings. So we are adding various strings over here. So we are adding elements like apple, banana, orange in the array list over here. So next thing that we are going to see is we are going to access elements using index using the get method. Okay. So what exactly we are going to do is, in this case, if you can see, so we have just after added, we have printed the respective list. So it is going to print apple, banana, orange, and get method is basically used to access the element. So what we are saying that we are going to fetch the index one in this case. So if you fetch the index one, what are we going to get, guys? We are going to get banana. Okay, you can see we are going to get banana. So get is used to fetch the respective index, and index starts from 0. Now, the next thing that we are going to do is, guys, we are going to iterate over the array list using the enhanced for loop. You can see over here. So now enhanced for loop is going to iterate between all the array lists. Like for example, in the first case, it's going to be fruit is going to be apple, then it's going to be banana, then it's going to be orange. And that is what we are going to print individual fruits using this enhanced for loop. So this is how we iterate through the array list using enhanced for loop. And in case if you want to remove an element, guys, we'll use a remove method. So this is called remove by value. Similarly, we can use a remove by index where we can give the respective index. So in my case, I can remove by value as well as we can do it through the index. So as we can see in the first case, we are removing banana. Okay. And then we are saying that what are we printing? So after removing banana, what do we have in the square bracket? Apple and orange. And after removing 0, so now what was my 0? Apple. So after removing 0th index, what is left out, guys? Orange. Okay. Now, the next thing that we are going to do is, guys, we are going to check if an element exists in the array list using the contains method. Now, the contains method, how do we check that, guys? We are going to quickly see. We have given a search element as orange. Now, what are we saying that if in my current array list, if the search element exists, then we are going to print that this exists in the array list. Else, it will print that the search element, for example, in our case is orange, does not exist in the array list. But after removal, orange still consists in the array list. So for us, it is going to print that orange exists in the array list, as you can see here. Now, clear is going to clear all the respective values from the array list. So array list.clear is going to clear all the respective elements. So after clear, you can see there's no values into it. Then we are again re-adding various elements, grape, mango, and pineapple. And then what are we going to do is, so now there are two ways of doing it. One is through enhanced for loop iteration, and the second way is to use an iterator itself. Now, what is exactly iterator? How do we use it? So we'll use iterator what type is it. So it is going to be a string type iterator, and what and how to get all the values basically. So array list dot iterator will iterate through all the values. So iterator is going to iterate between all the values that you see in the array list. So dot has next. Can you see, while we are using while loop where iterator dot has next, what is it going to check? It is going to iterate until you are going to get, and until you are going to iterate through all the values. At the end, when no values are left out to iterate, in that case it will has next is going to give false. And but let's say if it is starting from grapes, mango, and pineapple, so the iteration dot hat index is going to be true, and that is what we are going to print. So iterator has next is going to give us grapes here in this case because it has a value. Dot next is going to give you a respective value. And so if we continue ahead, grapes, mango, and pineapple, after that it will come out of the loop. So that is about the array list, guys. Okay, so guys, next thing that we're going to see is vector class. So vector class implements a global array of objects. So it falls in the legacy class, but it is fully compatible with our respective collection, and it is also part of java.util package, and it implements the list interface. Okay, so vector also implements a dynamic array, means it can grow a string as required. Like an array, it can also be accessed through the respective index. It is very similar to array list, you can say. So one more thing, as I was saying, the difference between array list and vector is going to be that vector is going to be synchronized. It's similar to the, if you see the process, it's similar to that, but uh, in our case, vector has a similar insertion order also as of array list, and it as you said, it is synchronized, so multiple threads cannot happen. So in that case, it gives a poor performance if we are trying to use in the threaded environment where we are going to add, search, delete, and all. Okay, so we'll see in our case how exactly we use vectors, guys. So in the respective example, if you see, we are going to use a vector object over here, and the type that we have defined for a respective vector is going to be integer. So we are adding 10, 20, 30. And as we discussed for array list also, similarly for vector also, get is used to access the respective values. So we are going to access all the respective index as 0, 1, 2. Okay, so I'll get my respective outcome as at index 0 is going to now the next thing that we're going to see is, you can see element at index 0 is 10, 20, and 30. That's what we're printing. Now iteration also, like array list we saw before, we are going to use enhanced for loop over here to iterate between the respective vectors here. So it will print the each elements over here, as you can see in my console below. 10, 20, and 30 is getting printed. Now here also we'll use contains to check a specific element if it is present in a vector or not. So I've given my search element as 20, and it will check if my vector contains the respective search element. If it contains, then it will print that respective search element is present in the vector, else it is not present in the vector. Similarly, for removal, what I'm doing is I've given a remove element. We'll check whether that respective element is present. If it is present, I'll remove that element, and we'll say that I've removed that element. So how do we use it? We used a remove element method over here, which is already defined in the vector class. Okay, in array list we are using remove. Here we are use remove element. Okay, guys. So that is what we are going to do. And to check the size, we use vector dot size. Similarly for array list also, if you need to find the length, you can use arraylist dot size to give you the length. And clear is also used to clear the respective vector. Similarly, as we saw, it is for the array list. So it's just on the implementation, how it happens on the backend, that you will see the performance improvement in case if you use an array list. But in the functionality wise, it is similar as we saw it for the array list. Yes, now we'll see an implementation for a different type of basically class that we have, that is stack, which also uses list. So we will understand what exactly is stack. Okay, so what exactly stack basically, guys, is that it basically works on the principle of LIFO, that is called as last in first out. So it basically performs push and pop operation. Push is generally to add, like you can think pop is to remove. Okay, so uh, we have various three functions that we use: empty, search, peek. We'll see the implementation of it. Okay, now what we can do is, guys, let us understand how basically stack basically looks like. So you can think of in a container. So generally, just let me share my whiteboard. Okay, let's think stack as a normal container that we have. Okay, we have various values like 10, 20, 30, etc. So, you can think that once 10 has been added, so 10 is the first element, so will get added at the bottom here. Okay. So similarly 20 on top of it and all. So this is what push is going to do. Pop is going to do reverse. So pop will first remove the topmost element, or the element that you see from the top. So that is what pop operation is going to do. So we'll see, it will remove the top element. So basically last in and first out. Okay. So it is going to work on that. So let's say if 30 was the last element that was entered, and if I do a pop operation, 30 will be the first element that will come out of it. Okay. Now let us go back to our respective screen for the program. Guys, now let us start with the respective program implementation for this stack. What we are doing is we are creating a stack for integer type. So so my stack will have all the respective integers, and I'm pushing 5 numbers over here: 10, 20, 30, 40, 50. And then we'll do a peak over here, guys. So once we do a respective peak here, what we can see is the top element that you see on the top is 50 here. Okay. And then pop, as I said, pop we are going to remove. So if I do a one pop operation, the first pop operation will remove 50. Then the second pop operation will remove 40. And then we're checking, is our stack empty? So use is empty to check if first stack is empty. In our case, stack is not empty. So that is the that is what it is returning false. And in case, how do we use a search? So we use a search by using stack.search given search elements. What are we doing is we are trying to find the position, which position, where if which position my respective 20 is there. So if you see 20 is at my current position as 2 in this case. If I give a number which is already popped out, in this case, let's say 50, I'll get position as -1 and will give a return as element not found because I've already popped that value. Can you see that, guys? So this is about stack. Guys, next thing that we'll understand is linked list. So what exactly linked list is, guys? So this is also going to be the part of the list interface itself, which will going to implement that. So so what exactly happens is in the linked list, it acts like a dynamic array, and we do not specify the size while creating. The size of list automatically increases when we are dynamically adding and removing the elements. Okay. But what happens with a normal like um, so so in the linked list, these lists are interlinked to each other. Okay. And these interlinking, or a basic principle of how exactly we also have a category, something called as double linked list, means you will see that a respective indexes it will have a head and node. To give you an understanding, let me quickly share my uh, respective whiteboard. We'll see an example over here, as you can see. So what we see is in a linked list, generally you will see two aspects of it. A node generally be something called as node. Okay, so a node will always have a head, okay, and a respective next address that it will store. So and a respective value. Okay. So these heads that you're seeing right now, okay, so basically initially the head is going to be initialized as null. Okay. uh, because the previous element is not there, whereas the next element, it will store the address of the next element that we have stored, in this case 4. So my next will contain the address of the next element 4 here, and my previous is going to store the address of the previous linked element. So that is the reason it's called double linked list. So it is linked from both the sides, whereas the linked list, it will always be a structure. I'll just give you an example for the structure for linked list as well. So guys, as we can see in the linked list data structure, this is for you guys to understand. So in linked list data structure, we see that we have a head, okay, and generally we have a node. Node will have data and the address of the next element, whereas double linked list would always contain the previous element along with the data. Okay, that is the reason it's called double linked list. Whereas the linear linked list that you see over here, this would contain, the node would contain data and the next. So we'll start from head. Okay, so head will redirect to the respective data, and this next will contain the address of the next node. Similarly, these are interlinked, and the last element that you see, what happens is the next value, that the next value, or the next value of the node, last node, is going to be redirecting to null because there's no element ahead further over there. So similarly, let us look into the implementation, guys. Now, if we see the linked list implementation, we will see its similar implementation over here. So linked list we are going to create as part of strings. We are adding apple, banana, orange here. And here we are iterating through the iterator. Okay. So we use an iterator, and linked list dot iterator will contain all the elements like apple, banana, orange. and it is checking if the iterator has some next value. It will iterate until all the values are iterated, and that is what we are printing over here in the console that you can see. So elements contains apple, banana, and orange. Okay, and then what am I doing is, guys, if you see, I'm adding, so I can give index also while giving a respective value here. So index, what I'm saying it, so I need to add mango at my index 1. I can do that also for my uh, array list as well as for other lists also. So I can give my index. So let's say I'm saying I need to add mango at index 1. So the subsequent index that we had will get pushed. So mango will get pushed to index 1, banana would get pushed to index 2, orange will get index 3. So that is after adding, that is what it looks like, if you can see. And so as I told, we can use iterator or we can use enhanced for loop. So in the second case, we are iterating to print using the enhanced for loop. Now remove method is used to remove a respective element from the linked list. So after removing, we'll see, after removing banana, the list of elements are apple, mango, and orange. Okay, and then how do we access? As I said, we access it through get index you can get, or respective values you can fetch. So it will basically get you respective value at the respective index 2. It is going to give orange, and using contains you can search a respective value. So in this case, I'm checking if my orange is present or not. So if my orange is present, it gives true. In this case, you can see, guys. And then we are finding the size. So size, you can use it, all the list you'll use dot size to give you the basically length of the or the number of elements that are present in the linked list. And clear is going to clear the respective list, and then we'll use is empty to check if the list is empty or not, the linked list is empty or not. In this case, after doing, we are clearing it off, so the list is empty, it is giving true in our case. So this is was an example for the linked list, guys. In further sessions, we'll explore other topics. So if you really like the video, guys, please like the video, subscribe to my channel, and comment in case if you have any queries, and share with all of your friends ahead. Take care. Bye bye.